Our skill tree isn't much of a skill tree if we don't have the skills visually connecting to each other. So let's work on something that, instead of having to set up images to connect everything manually, because that's going to be a hell to do, we want to connect these up automatically. In the last video, we already set up a system where every node has a list of references to nodes that it needs to connect to. So all that we need to do at this point is take this list of nodes in each one, which I'm trying to find the right widget. There we go. Take this list of nodes and just say, hey, draw a line from this node to that node and from this node to that node. That's pretty much as simple as it is. But how do we do that? Well, if we're here in our actual skill tree widget, you might remember that at some point in the past, we added this image in here. Also, now that we're working more and more on this skill tree widget itself, you might also notice that if you scroll away and you don't have the actual bounds of our desired on screen or our fill screen, like this dotted line on screen anymore, everything inside of it kind of just stops rendering at some point. The way to kind of change that around is just to set this to desired. So that way our dotted line will expand to fill its entire content. So now everything will always just render no matter how far we pan or scroll away. Anyway, this image is what we are going to be working on, because we have got this background image that I put in just so that we have a clear edge to our skill tree widget. This image is going to be replaced by an image that's also going to be drawing the lines on top of itself. So Unreal actually has a built-in handful of functions that can let you draw lines in your UI widgets. The issue, though, is that those draw always on top. So we can't do it within this widget, because what would happen if we did it here is it would draw the lines all the way on top of everything else. So we have the line going from here to here over top of our nodes. We don't want that. So we're going to be making a separate widget that we give in the positions of all the lines that we want to draw. That widget is going to be taking the place of this image. And then that is going to draw all the lines on top of itself. And then all the nodes in the skill tree will be drawn over top of those. That ends up being a little bit janky in some ways, but it makes the math a lot easier than having to offset every line into certain directions based on angles and that kind of stuff. So what we'll do is I will go in here, I make a new widget, blueprint, user widgets, and I'll call that WBP line drawer. If we open that up, what I'm going to put in here is I'm going to still put in an image for the background color. We'll set the color and opacity for this to being a similar like dull gray, maybe make it a little bit blue just to make it a little bit more pleasant. And there's nothing else going to be in here in terms of widgets. We just immediately dive into the code. Now in here, we want to make an array. And you can see I already have a draw spline here. I've been trying to figure out a couple of different things. We have a whole bunch of just drawing information structs in Unreal. You can probably use one of the draw line ones. We've got this debug line and then draws a line in the viewport given a start and end. And then we also have another one of those. The thing is, these are part of the unit debug line system. So I'm not 1000% sure that these will show up properly in your packaged builds, because these are usually used by the debugging tools. The struct itself might not be available outside of development and in editor builds. So what we're going to be doing instead, just to be sure, is I'm going to make my own struct with the information that we care about. We have this struct that we make in just blueprint structs. We'll call it str line to draw. And there we can give in the starting point. So we can call that point A. Since we're only doing this within the widget, within our UI, we only need this to be two-dimensional. So we can do a vector 2D. And then, of course, we also need a point B. And the reason that we're doing this in a custom struct is because now we can also give in something like the thickness of said line. So it'll be a float, and we can give in the color of the line as well. And that'll be a linear color. or maybe just slate color. I think linear color should be fine. And with that made, we can come back into the variable that we just made, give it a name as well. I thought I did that, but I didn't. Lines to draw. And we can make that of our new type line to draw. You'll see that we have all of the information that we want to give in there. Of course, array important because we're going to be drawing a lot of lines. We'll set the value for this in a moment because we're going to be setting the value for this from our actual skill tree widget itself. We're going to be giving this in. But before we go back there, let's just finish up this part of the system first. So we're going to override a function, and the function that we'll override is onPaint. onPaint is the function that you use to draw in extra primitive shapes, like boxes, lines in this case. I believe it might even be like drawing circles and that kind of stuff for your widgets. It gives you in the paint context that you need to actually run those functions. So what we do is we get our lines to draw. There we for each loop over the entire array. So for every single one of the lines in this array, we're going to be drawing, well, who would have guessed it, a line. We simply draw a line, and you don't mistype it. So you can see here we've got draw box, draw line, draw lines. You might think that you want to draw lines instead of just draw line. The difference here is this draws a single line. This draws multiple lines that are connected to each other. But since we don't have one continuous line that we want to draw, we want to have split parts in our lines, we're going to be drawing them individually instead. You can also draw a spline and some text. We've got some debug stuff here. I think this is all for 3D, and this is all for painting. This is for UI, 2D. So we're going to be doing a draw line. That needs to take in a painting context, which is why we do this in onPaint. And then we give in a position A, a position B, a tint, and a thickness, and whether or not it should anti-alias. And the great thing is, we just make that struct that has all that information inside of it. Now, there is one catch to it. We can't just put this through one-to-one, because this is going to be a little bit annoying. But we're going to be putting this into our skill tree offset by half its size. It's going to be anchored to its center. If we go back to the skill tree right here, you will see, can I zoom this out anymore? No. But we've made this thing 15,000 by 15,000 units. I'm just going to make this like 5,000 by 5,000 instead, so that's a little easier to fit on screen. Its alignment is 0.5, 0.5. If the alignment were just 0, 0, we would have it outline from the top left and just 5,000 extended away in the right and down directions. We want it to be aligned to the center, so that if we make it bigger, it grows in every direction. So it is aligned to 0.5, 0.5. Our line drawer is going to be the same way. The coordinates that we give in need to not draw from this point, which it will do by default. It will need to take in the coordinates of these things and then add the half size of the actual background to it so that it properly draws the coordinates from its actual origin point. That doesn't make sense. Just follow along and hopefully it'll start making sense in a moment. So the way that we set that up is we need to get the actual size of how big this thing is. We can do that in a number of different ways. The way that you usually use for things is getting the cached geometry. Since this is going to be on a canvas panel, what you could technically do as well is get slot as canvas slot, and you can just get a reference to self in it, and this will have a get size. This oftentimes will also work, but this only works when things are actually inside of a canvas slot. So it's a good habit to get into to try to use cached geometry wherever possible, because this even works when you're not inside of a canvas. Anyway, we try to get the local size of this thing, and that's just going to tell us, okay, how big is this thing in the context to its parent. And since we want to offset our x and y coordinates for both the A points and the B points by half the size of this square or rectangle, all we need to do here is really divide this by, just to make this easy afloat, divide it by 2. So if this thing is 10,000 units wide and high, this is going to output 5,000, which is exactly the offset that we need. So then we just take out point A and we add that offset to it. That is what we're going to be putting into our position A, and the same with point B. We just add that offset to it, and we put that into position B. Then we can just pull through the tint as the color and the thickness as the thickness, and that should pretty much be all there is to it. Now, at the end of this, it is good to just hook up the completed to the return node, and that's everything the line drawer itself needs to do. Constructing the lines for this array is going to be a little bit more involved. Let's immediately just move on over to that. Back in the skill tree, what we're going to do is I'm going to remove the background image that we've been using so far, because we're going to be replacing that with our new line drawer. So if we just do a line drawer, and we make sure that that's the first thing in our stack, because widgets render from bottom to top, so it renders this first and everything under it gets rendered after it. I need to figure out where this thing is, first and foremost. We align this to the center, and we set the alignment to being 50% and 50%, and then we set this back to the same size that we had before, which I think was about 5,000 by 5,000. Sometimes it's a little tricky to find these things in your widget view after you've changed the size. You can, of course, try to figure out where it is based on these coordinates up here. If you really can't find it, you just close it, and then you reopen it. So if I reopen it, it just reopens it centered on there. So there we go. And now we've got this line drawer here. So make sure that that's variable, and we can go into the graph view for the skill tree widgets. And here we'll make a new function, and that'll be get lines to draw. This is going to be returning an array of lines that needs to be drawn. Let's add in an output, and this will be lines to draw, which will of course be of type lines or line to draw, I think we called it. Yeah, that struct that we made. And that's going to be an array. We're going to construct this array within this function. So the way that we usually do those things is you just return a local variable. Let's call that local lines. This way, you can be sure that every time you enter this function, it just makes a new fresh version of this array. And you can just populate this array one thing at a time. And then at the end of the function, you just return the array that you've constructed. Now, how do we get every single line between every single one of these nodes? This is the difficult, this is the tricky part, right? We already have a reference to our canvas panel in here from a previous video. If you've skipped over that, you shouldn't do that. But you can go back into the designer here, make sure that the canvas panel is selected, and check whether or not it is variable. By default, it won't be, but because we've already used this as a variable in code before, I've already set it to variable. We get that as a reference, and then we get all children. There, we're going to for each loop over those. Now, every child of this, pretty much in all cases, aside from the line drawer itself, is going to just be our skill tree nodes. If you have anything else within here, that's not really a problem, because the next thing that we're going to do is we need to cast this to our skill node anyway, because we're going to be getting some information out of the skill node, namely that being which nodes it's connected to. So we need to do this cast anyway. This also immediately functions as being a filter. So we get the next nodes, and there we, once again, for each loop. Do be mindful that whenever we are trying to get all the lines to draw, we're going to be looping over our entire array of nodes, and every one of those is going to be looping over the array of nodes that it is connected to. So if you have a very big tree, this might end up getting fairly expensive. You might only want to update this whenever you actually know that something has been updated. If you're not doing anything regarding updating the color or the thickness of your lines, really the only time that you need to run this would be on event construct, because the lines themselves aren't going to be changing between the nodes. That would be preferable. If you do want to dynamically change the colors or the thickness of the lines, ideally only run this get lines to draw thing whenever you actually know something has been updated. Don't just throw this into event tick. This will add up fairly quickly. Even though the actual operations that we're going to be doing aren't going to be that expensive, all that we need to do is we need to get our local array that we made, and we need to just add something to it. We'll just split this structure up in. We need to add a point A, a point B, a thickness, and a color. And how do we decide all those? Well, that's going to be the trick, isn't it? I'm just going to set thickness to 2 for every single one of these. Let's focus on the point A and point B first, and then we'll finish off with the color. The color is going to be fairly straightforward. The point A is going to be coming from the first thing in the loop here. So that's going to be coming from our cast to skill node. And if you think back to one of the first videos in this series where I said, well, we're going to be putting our skill tree within a canvas. There's 2 reasons for that. It allows us to easily put these things in whatever order we want, wherever we want, in whatever shape we want. That's the main thing, because you could render them with a different offsets in a overlay if you really wanted to and that kind of stuff. This is the other side of that, is because if we have a canvas slot that simply has a very easy just get position node, which gets us the XY position of any given node that we're working with. So this is going to get us the top left of all of those. There's 2 different things that we can do about that. Is we can either go through every single one of these nodes and make sure that they are much like the actual line drawer itself, aligned to being 0.5, 0.5. This will make that pivot point their center. So it'll regard their position as being calculated from here instead of from there. That is fine. That is a good way to do it. It might become tedious to have to do that for every single one that you add, though. And there's no real other benefit generally to doing that. And if you miss one, it's going to be weird. It's going to look ugly. So what you do instead is we get the desired size of the widget. The desired size is just how big do I want to be? And in this case, note that we set up here, we set that to size to content. So this is always going to be forced to be at its desired size anyway. So the desired size should do everything that you need it to do. Then, again, very much the same as we did before. We need to divide that size by 2 because the size is the, well, size as a whole. If we divide the size, we just get the middle point. Adding these 2 things together gets us the middle point of our widget in the parent screen space. So we put that as point A. And then pretty much point B is going to be this exact same bit of code. So what you could do is you could collapse this to a function, collapse to function, and we call this something like get node position. And if we open that up, these are both going to be the same reference. So we can delete the second one here, call the input node, and the return value position. And let's make that pure as well, so that it doesn't have the execution pins. So we just get the node positions from the skill node, and then we get the node position for each one of the nodes that it is connected to for point B. And then we only have the color left. And the color, we really need to just check, hey, is this node that we're going to go toward, is it open, which is a value that we made last time. So we get is open, and we just add a select color node here, and then we just put this is open in here. And then if it is open, we probably want this to just be white. And if it is not open, we probably want this to be like a dark gray type of color. And we just do that for every connected node, for every node in the canvas panel. And then once this first for each loop has completed, so if you're playing along here, do pay attention to the fact that this is a return node after the first for each loop, not after this one. So what this is going to do is it's going to do this loop for every single one inside of this loop. Only when the outermost loop is completed do we return. We return the array that we've constructed one thing at a time over here. Now, in the event graph, you can on-construct. I like doing it on pre-construct, so it also shows in the editor. You can just get lines to draw, that function that we just made. And all then we need to do is we get our line drawer and we set our lines to draw to the output from that function. Now, again, this might be collapsed into a single function where we can just call this all at once, where we can just collapse to function, updates node lines, because you might want to call this at a later date. Write a little bit of code for that in a moment. But as you can see right now, it's writing the code for everything. But as you can see, it is going from top left to top left, so that's not ideal. What you might need to do if this ends up happening is you are not actually giving in the desired size properly, because it doesn't have a desired size yet. The way to fix that is to go into the skill node itself, so this widget over here, and there on pre-construct, what we may need to do is we need to force layout pre-pass. This just makes it render its geometry once so that it actually has geometry to sample from and know what its desired size is. And you see immediately then everything is linked up properly now. So yeah, that's pretty much everything there is to making these lines. So if we now just open this up, we can see if I unlock this, the lines don't update yet because we only set these lines up once. So now every time we unlock something, we want to be able to, in our skill tree widget, update our lines to draw array as well. So there we just need to make sure that every time we click on either new node selected, or what's actually probably better is if we go into our skill info. I'm kind of improvising here because this is not in my initial test project. But if we go into our skill info, we probably just want to have a event dispatcher linked to whenever we try to unlock a skill. So event dispatcher here, new skill unlocked. And whenever we have a new skill unlocked, it doesn't need to go through and send any information. It just needs to say, hey, a new skill was just unlocked. You probably want to update a bunch of stuff with your lines. So now that we have that, we can go back into the skill tree, because we already have our or skill tree menu rather. So this one, we have both of these widgets exist side by side, because here we have our skill tree info, and there we now have the new skill unlocked event that we can run any code on. So we get our skill tree, and there we just update, if we can spell it properly, update node lines whenever we unlock a new skill. And that should then update the node lines as we unlock skills. So you can see I've unlocked this one now. The line going to this one and this one is now white, and so on and so forth. So that's everything to do with the line drawer. It's pretty straightforward. You just need to really know that this is a thing that you can do in the Paint event. And with that, it's starting to look like an actual skill tree, which is fantastic. A little bit of code left to do, which is saving this stuff, fairly important, and then being able to pan and zoom in and out over it. So we're getting there. 2 more videos to go, and then we'll be. In the meantime, if you want the project file in its current state or the finished project file with those things implemented, you can check out the link down below for YouTube members and patrons if you really can't wait to see the final parts of how this comes together. And a very big thank you to all my Patreons. You can see them on screen right now. If you want to help support the channel or get any of the project files in any of my tutorials, there's a link down below to the Patreon page to support me, or alternatively as a YouTube member. My Cave Student tier supporters, Oiku, Earl, Monserville Erno, and my Cave Digger tier supporters, Mauricio Farias.